mentioned some work on looking at the effect of roughness on a fault and how that affects its behavior, including earthquakes and slow slip. I would say that as a community, we've only really scratched the surface in understanding the mechanics of rough faults. And for me, that's really one of the big topics that I want to deepen and understand fully in the next few years. I mentioned, for example, some encouraging results in which we've been able to reproduce some of the behavior of foreshock sequences, but we still have a lot of open questions, including what controls if we have foreshocks, or if they don't take place, what controls other types of seismicity. So if we have time-dependent changes in seismicity rates, how do we know that it's a foreshock sequence? And I think really looking at this, basically developing more realistic models, starting on the ones that I've been working on in the last couple of years. I hope to work with people who characterize faults using different types of measurements, for example using LiDAR that allows you to really look at the shape of a fault in much detail. I also want to think about the role of different types of rocks along the fault, work with people who do lab experiments that can really allow us to connect the details of the shape of a fault and the distribution of stresses with the seismicity that results from these aspects. Another aspect that is related to fault geometry and that's very interesting for me is looking at subduction zones. These are areas in which a tectonic plate subducts or sinks underneath a different plate, and the interface between the two is where the largest recorded earthquakes take place. And so there is some evidence that, once again, the geometry of this interface, the kinks and the bends, can really have a first-order impact in determining the seismic behavior and determining the final size of an earthquake or determining microseismicity. So, and we know that there is some complexity on the fault interface because the subducting plate has topography on it. It has seamounts and all the sort of relief that you would expect if you look at the ocean floor. And so now that we have some understanding about the role of geometry of a fault into the seismic behavior, we are starting to understand how these kinks and these bends and so on affect seismicity. One of the projects that I have for the next few years is really understanding what happens when a seamount subducts. How does that impact the seismic behavior? What does that mean in terms of seismic hazard?